Petrol engine and diesel engine are four-stroke practical engines. They have some fundamental differences in their working. A. What difference is there in the supply procedure of fuel in engine? B. What are the different processes occurring during the heat supply into the petrol and diesel engine? C. What are the main reasons of higher efficiency of diesel engine than that of petrol engine? Now, before discussing the question, let us understand what is stroke in engine. Okay, so we are going to understand this. Clear? Now we know petrol engine is also called gasoline engine. Okay, so in petrol or gasoline, okay, engine, the cycle involves, okay, it involves the execution, of 6 process. So we need to note this, okay. There are 6 process involved in petrol or gasoline engine, okay. And out of 6 process, okay, out of 6 process, 4 process, so I'm writing in short, okay, 4 require vertical motion of the piston and are called strokes. So we have this, okay. So there are 6 process and out of 6, 4 requires the vertical motion of piston and are called strokes. Now, I'm writing 6 process involved in petrol or gasoline engine, okay. So, I'm writing over here the 6 process involved in petrol engine are 1, okay, intake, stroke, 2, compression, stroke, 3, combustion, 4, power stroke. So we have this 5, exhaust, 6, exhaust, stroke. So we have this. So these are the 6 process, okay, and the distinct process, okay. So I'm writing over here the distinct process in petrol engine are 1, intake, okay, or intake stroke. So I'm writing in this way, intake stroke, 2, compression, stroke, 3, combustion, and power stroke, 4, exhaust, okay. exhaust stroke. So for this reason, petrol engine, okay, are called four-stroke, okay, are called four-stroke engine. So we have this. There are four distinct processes involved. So for that reason, petrol engine are called four-stroke engine, okay. So we have this. Clear? Now, let us discuss the process involved in diesel engine, okay. So I'm writing diesel engine. So four-stroke. So let me write in this way, okay. Four-stroke diesel engine. Now, in four-stroke, diesel engine, okay. In four-stroke diesel engine, the cycle involves the execution, okay, involves the execution of following process. One, intake stroke. Two, compression stroke. Three, combustion and power stroke. Four, exhaust, okay, exhaust and exhaust stroke, okay. So we have this. So these are the process involved in practical four-stroke, okay, four-stroke diesel engine. So we have this. Clear? We have this. Now, we can see, okay, we have discussed this question, okay, that is question B. So let me write over here, solution of B. Let us discuss A, okay, difference in the supply of fuel, okay, for petrol and diesel engine. So petrol engine, okay. So for petrol engine, we need to consider intake stroke, okay, in order to understand the fuel supply, okay, and compression, okay. We need to take intake and compression stroke and we need to consider combustion, okay, to understand the supply of fuel procedure, okay. So I'm writing to understand supply procedure of fuel, okay. So we need to understand these three, okay. Now, in case of intake, okay, stroke. So I'm writing over here. intake, stroke. So what happens in intake stroke? Okay, petrol vapor and air is mixed. The mixture is drawn, okay? It is drawn into the cylinder. Okay? Due to suction as the piston moves away, okay, from the previous position. So we have this. So let us understand in this way, okay? So I'm drawing. So we have this. This is a cylinder, okay? And this is a piston. So we have this. This is a piston. Okay? So the piston moves out, okay? Moves out. So we have a spark plug. So these are the spark plug, okay? And this is the inlet, okay? This is the inlet or opening, okay? And this is the outlet, okay? So it is closed. This is outlet and it is closed. Inlet is open, okay? So we have this. So what do you find? In this case, we find petrol vapor, okay? We find petrol vapor, petrol, okay? Vapor and air, okay, is mixed and the mixture is drawn into the cylinder, okay? So we have this. Now, in compression, okay? In compression stroke. So what we have in compression stroke is that the mixture is compressed until its pressure and temperature, okay, is very high. So the mixture is compressed, okay? So when there is compression, the volume decreases, okay? This volume decreases. The volume decreases. So we have this. Third, combustion, okay? Now, in combustion, okay, since the temperature is very high, we can see in compression stroke, temperature is very high. So what do you find in combustion? The hot mixture, okay, is burned, okay? It is burned or ignited, okay? Is ignited by electric spark. So we have this, okay? So these are the method or process, okay, which explain the supply procedure of fuel in petrol engine. And combustion, okay, this is very rapid, okay, process. So I'm writing this is rapid process. So it is very fast. And due to combustion, okay, due to combustion, pressure and temperature, okay, becomes very high, becomes very high, but volume do not change. So this is to be noted, okay. Volume do not change for short time, okay, for short time. So we have this, clear? We need to note this. Volume do not change for short time. And the piston remains at rest, okay. It remains at rest in this rapid process. So this is to be noted, okay. Now let us understand supply procedure of fuel in diesel engine, okay. So for diesel engine, okay, procedure of fuel, okay. So we are going to understand this. Now in diesel engine, only air, okay, only air is admitted. Air is admitted inside the cylinder. Inside the cylinder. So we have this cylinder in intake stroke. So we have this. The air is compressed. The air is compressed, okay, adiabatically. It is compressed adiabatically until the temperature is high enough to ignite the oil, okay, to ignite the oil, that is diesel, or let me write in this way, clear, that is sprayed into the cylinder, okay, into the cylinder after compression. So we have this process of fuel supply in diesel engine, okay. Now Question C, okay. What are the main reasons of higher efficiency of diesel engine than that of petrol engine? Okay. So we need to compare efficiency of diesel engine and petrol engine, and we need to explain why the efficiency of diesel engine is greater than the efficiency of petrol engine. Okay. So let us discuss it. Efficiency, okay, of petrol engine. So let us understand this, okay. So I'm writing in this way: efficiency of petrol, this equals 1 minus, okay, we have this T1 by T2, and T1 is the temperature, okay, at the beginning of compression stroke, at the beginning, okay, at the beginning of compression stroke, and T2 is the temperature at the end of compression stroke, okay. This is temperature at the end of compression stroke. So we have this. Clear? Now, efficiency, okay. So I'm writing over here. Efficiency of diesel, okay, engine is, so I'm writing in this way, okay. Efficiency of diesel engine equals 1 minus 1 by gamma, okay, times 1 by rho power gamma minus 1 times e power gamma minus 1 divided by e minus 1. So this is the required expression for the efficiency of diesel engine. So we have this, okay, and rho, okay, is the adiabatic expansion, okay, expansion ratio, and E, okay, E is called fuel cut-off, okay, this is called fuel cut-off ratio, fuel cut-off ratio, or it is also called combustion expansion ratio, and gamma, this is ratio of Cp to Cv. So we have this, okay, for diesel engine. Now for the same compression ratio, okay, so I'm writing for the same compression ratio, the efficiency of petrol, okay, the efficiency of petrol, or it is also called auto cycle, okay, or auto engine is more than that of diesel engine. So we have this. In practice, okay, we find in practice the compression ratio for petrol engine is from 7 to 9. Okay, so we have this value. Compression ratio for petrol engine is from 7 to 9, and the compression ratio for diesel engine, okay, the compression ratio for diesel engine, okay, is from 15 to 20. So we have this, okay. So this is to be noted. Due to higher compression ratio, actual diesel engine has higher efficiency than petrol engine. So I'm writing conclusion, okay. Due to higher compression, we can see, okay, compression ratio for diesel engine is higher, okay. So due to higher compression ratio, okay, higher compression ratio, actual diesel engine has higher efficiency than petrol engine, okay. So we have this. Clear?